Hello everyone, this is Mr. Zimmerman, and today we're going to be looking at section 7-1 in geometry. So let's take a look at what's in this box at the top of the page here first. The first thing we have is a definition of a ratio. It's a comparison of two quantities by division. And then it shows the various ways that you can write ratios. So the first one is x to y. You can also write it as x colon y, or you can write it as x over y. Now it's important later on, when it says x to y, the quantity that's first goes on top when you write it as a fraction, and the quantity that's after the word to, that's in the denominator when you write it as a fraction. All right, and then it talks about the slope as a ratio, and our first example problem will use this formula right here. I think you guys remember that's the rise over the run, or it's the change in y over the change in x. And we're also going to have an example where we talk about extended ratios, and that's where we compare more than two quantities. So let's go ahead and take a look at example 1. The first thing we need in example 1 is we need to write down the ordered pairs with the coordinates for points A and B. So let me do that for you. We have point A is 3 left and 1 up, so the ordered pair is -3, 1. And point B is 3 to the right and 3 up, so the x is 3 for 3 to the right, and the y is 3 for 3 up. Now let's use our slope formula. Our slope formula was given in the box above. Again, remember the y's go on top. It's the change in y over the change in x. I like to set up our ratio for the slope, leaving blanks in there like this. Also, I set that up in red, and now we're just going to plug the numbers in. My y values are 3 and 1. And then in the same order, using this point first and this point second, my x values are 3 and -3. So then I'll go ahead and simplify this. So I'll get my slope is equal to 3 minus 1 in the numerator, that's 2. And in the denominator, you can see that whenever we subtract a negative, we actually add. So that's going to be 3 plus 3, which is 6. Then we would want to reduce this fraction, or this ratio, and we could divide the numerator and denominator by 2. So in the numerator, we'd have 2 divided by 2 would be 1, and 6 divided by 2 would be 3. And so that would be our answer for the slope for number 1. Let's move on to number 2. So in number 2, this time they didn't give us a graph or a picture. They just gave us the coordinates of the 2 points, and we want to find the slope. Now we know that each of these ordered pairs, the first coordinate is x and the second coordinate is y. So again, we're just going to set up for our slope ratio. So I have this set up for us. I've already put the subtraction signs in there, and remember that the y's go on top for this. Our y's are 5 and -1. And our x's, again, going in the same order, starting with this point right here, with this x coordinate, are -2 and 3. In the numerator, we have 5 minus -1, and we know when we subtract a negative that we add. So our numerator is 6. In our denominator, we have -2, take away 3 more, Well, that's going to give us a -5. We have a slope of 6 over -5, but generally if I have a negative in a fraction, I could leave it in the denominator like it is here, or I could put it out in front of the fraction bar, but I think it's best probably to put the negative into the numerator or into the top of the fraction. So I would have my answer as -6 over 5. So that would be our ratio comparing the change in y to the change in x. So, and if you remember slope, that would mean that you would move from a point on the graph to get to another point. You would go down 6 units and then right 5. In number 3, the ratio of the side lengths of the triangle is 2 to 4 to 5. Well, that means there's a common factor x for these 3 side lengths of the triangle. So we're going to draw a little model for this one. And this model that we draw, it doesn't have to be to scale. It's just a model to help us do the problem. So what we're going to do is we're going to label the sides now. The ratio is, again, 2 to 4 to 5. So we're going to label the one side length 2x, another side length 4x, and the third side length then is 5x. And then it says the perimeter is 55. So what we have to do then is add all the sides together and set it equal to the perimeter of 55. So we've got 2x plus 4x plus 5x equals 55. And then we'll simplify that. Well, we've got 2x's plus 4x's plus 5x's, so that gives us 11x's equal 55. And then we'll divide both sides by the number out in front of the variable, and we'll get x equals 5. All right, now we're not done. We've got x equals 5. It says to find the length of the shortest side. Well, the shortest side would be this side right here, 2 times x. So we know the shortest side then is 2 times x. So 2x, well, we're going to plug in the 5 that we got for x right there. So that's going to be 2 times 5. And then we have the shortest side is 10. And I guess since they told us that this problem was in centimeters right here, that we're going to include units on our answer. So it would be 10 centimeters. In number 4, we have a very similar type problem. Again, we've got a ratio here of the 3 angle measures in the triangle is 7 to 13 to 16. All right, so again, there's going to be some common factor x for those 3 angle measures. So again, I'm going to draw a little model for this one. So I've drawn my model again of my triangle, and again, it doesn't have to be to scale or in the correct perspective. But what I do know is that the ratio of the angles is 7 to 13 to 16. So what I'm going to write in here then is I'm going to write that this angle is 7x and that this angle is 13x and this angle is 16x. All right, well then, what do I know about the measures of the angles inside of a triangle? Well, they have to add up to 180. So that's what I'm going to do. I'm going to add them up and set them equal to 180. So I've got 16x's plus 13x's plus 7x's equals 180. And then I'm going to add the x's together. I'll get 16 plus 13 plus 7. That's going to give me 36x's equal 180. And then I'm going to divide both sides by the number out in front of the variable. And I'm going to get x equals 5. But again, I'm not done. I found x, but I need to find the measure of the largest angle. Well, the largest angle would be 16 times x. So that's 16x. And then what I want to do is I want to take my 5 that I found and plug it in right there. So I'm going to do 16 times 5. And I get 16 times 5 is 80 degrees. That would be my largest angle in the triangle. Let's take a look at what's in this box on the bottom of the page. What you have is the definition of a proportion, and it's two equal ratios. So basically just two equal fractions. And then there's this next statement here that says the product of the extremes equals the product of the means. I think that will make a lot more sense to you when we look at this a little bit different way on the top of the next page. But for now, let me just write this down for you. So what I wrote down is that the product of the extremes, A times D, is equal to the product of the means, which would be B times C. So that's what I wrote down here for you right here. But I think you'll understand that better when we look at the next page. So all you had to really get out of this is that a proportion is two equal fractions, okay? Two equal ratios. So what we have on the top of the next page in this box, I think this is a lot better way of looking at the same thing that was in the other box. So what we have is a proportion again. So it's two equal fractions, okay? And then here's what I wrote down on the bottom of the previous page. But basically what you want to see is that the cross products are equal. So if you multiply A times D, that has to equal the other cross product, which would be B times C. All right? And that's the way we're going to use these proportions to solve problems. Let's look at example 2, number 5. And again, how we're going to solve these proportions, what we have is two equal fractions. So we're just going to set the cross products equal. So we're going to do this cross product is going to be t times 36. And we're going to set it equal to this cross product, which is 9 times 28. So let's go ahead and do that. So we're going to write t times 36. That's the same thing as 36t. That is going to equal the other cross product, which is 9 times 28. We have 36t then is equal to 9 times 28 is 252. And then we're going to divide both sides by the number out in front of the variable. So we divide both sides by 36. And we get t is equal to 7. All right, well, let's try the same thing on number 6. On number 6, we're going to do this cross product, 22 times x plus 3, and we're going to set it equal to this cross product, which is 11 times 10. We have 22 times x plus 3, but that's times the quantity x plus 3, so we need to put that in parentheses. And then that's going to be equal to the other cross product, which is just 11 times 10. Well, then from there, I think you can see that we're going to need to distribute. So we're going to distribute the 22 onto the x and onto the 3. Some of you might have noticed that the right-hand side of this is 110. And actually, you could have divided both sides by 22 because 22 divides evenly into 110. But if it didn't divide in there evenly, you wouldn't want to do that. You wouldn't want to divide both sides by 22. So I'm just going to go ahead and do it the way you're probably used to, and I'm just going to distribute the x. That'll work. Distribute the 22. That'll work fine. So we'll do a positive 22 times x. That'll give us 22x. And then we'll do a 22 times a positive 3, and that'll give us a positive 66. Then we'll just subtract 66 on both sides. On the left-hand side, 66 minus 66, that's 0, so that'll cancel out. So on the left-hand side, all we have is 22x equals, and on the right-hand side, 110 minus 66 is 44. Then we'll just divide both sides by whatever number's out in front of that variable. And I think you guys can see here, then we get x is equal to 2. Moving on to number 7. Again, we're going to do our cross products and set them equal to each other. So we'll have 10 times the quantity x minus 9. That has to be equal to 15 times the quantity 2x minus 9. I'm just going to go ahead and distribute on both sides. So I got positive 10 times positive x, that's a positive 10x. And then I got a positive 10 times a negative 9, that's a negative 90. That's going to equal. Then I'm going to do 15 times a positive 2x, that's 30x. And then I'm going to do 15 times a negative 9, which is a negative 135. Okay, now this equation has variables on both sides. We need to get the terms containing the variable x on the same side. So normally we do that using addition or subtraction. So in this case, I'm going to subtract 10x on both sides. The 10x's are going to cancel out on the left-hand side. So on the left-hand side, I'm left with a negative 90. Don't forget to bring this subtraction down, right? That subtraction implies that that's a negative 90. And that would be equal to, on the right-hand side, we have 30x's take away 10x's. That leaves me with 20x's. And then minus 135. Now we're down to a two-step equation here. So we'll add 135 on both sides. So on the left-hand side, now we'll have 45 is equal to, on the right-hand side, negative 135 plus 135, that's 0. And so on the right-hand side, we just have 20x. Then we'll divide both sides by 20. And we'll have x equals 45 over 20. Well, if we reduce that, we could divide the numerator and denominator both by 5. That would give us 9 over 4. And I guess on this one, if you wanted to, you could put that in your calculator. And if you do 9 divided by 4, you should get, well, it would be 2 1/4. So, or 2.25. In number 8, we're going to do our cross products again like this, 2a times 3a, and then set that equal to the other cross product, which would be 3 times 8. We have 2a times 3a equals 3 times 8. Now we need to be a little bit careful with this. We know that 2 times 3 is going to be 6, but then we have to do a times a. Now that's not a plus a, that would be 2a. This is a times a, or a times itself. Well, that's going to be a to the second power, and that's going to give us 6a squared is equal to, and on the right-hand side we have 3 times a, which is 24. Well, we're trying to solve for a, so we do want to get this a squared by itself first. So we're going to divide both sides by 6. So divide the left side by 6 and divide the right side by 6. And over here on the left-hand side, 6 divided by 6, that's 1, so that cancels out. So all I have left on the left-hand side is a squared equals, and 24 divided by 6 is 4. Well, we want to solve for just a. We don't want a squared. So somehow we have to undo the square. So to undo the square, we're going to take the square root of both sides. So I'm going to take the square root of the left-hand side. So the square root of a squared is equal to the square root of 4. Now, in this problem here, this is really just an algebra problem. So whenever you take the square root of both sides of an equation, you've got to put a plus or minus out in front of this right-hand side because there's actually 2 answers to this problem. Now, if we were doing a geometry problem, we might not want to consider this case right there because, for example, when doing a geometry problem, if A represented like the length of a side, well, the length of a side can't be negative. But since there's no diagram or figure that goes with this problem, we're not solving for the length of a side, we're just solving for the variable A, then we do have to put the plus or minus in front of that right-hand side. And we're going to get two answers. So on the left-hand side, we do the square root of A squared, and the square root and the square here, they undo each other, and we just get A. And on the right-hand side, we'll keep that plus or minus in front of there, and then we'll do the square root of 4, which is 2. So you could leave your answer like that. That would be acceptable. But that really means A is equal to 2, and also that A could be negative 2. Now, number 9 is a little bit different. We have this given information that 5 times B equals 20 times C, and we have to find the ratio B over C. So what we're trying to do is just trying to get one B all by itself on top and one C all by itself on the bottom. All right? So we've got to try to get, I guess what we should do first is try to get the B by itself. Again, we're trying to get this ratio B over C. So we want just B by itself in the numerator. So if I wrote this equation for you that I rewrote right here for you, I would ask you, well, how do you get B by itself? And you guys would say that you would divide both sides by whatever number's in front of the variable. So let's do that. So over here on the left-hand side, 5 divided by 5, that's 1. That cancels out. So now I have B equals. Well, on the right-hand side, I can divide the 5 into the 20 right here because of this multiplication. So 20 divided by 5, that's going to give me 4, and then times C. Now, all I have to do to finish this is I want to get the C on the bottom, below the B. So I want C in the denominator on the left-hand side. Well, in order to accomplish that, what I'm going to do then is I'm just going to divide both sides by C. And now that I do that, the C's on, because of this multiplication here on the right-hand side, C divided by C, that's 1, and that cancels out. So I get a final answer of B over C equals 4. And that's what I wanted. I wanted to get the ratio, the question was to get the ratio of B to C, or B over C. So my answer is B over C, that ratio is equal to 4. Or you could write it as 4 over 1 if you want to. We have the same type of problem in number 10, but this time we want the ratio of X to Y. And we know that that means the same thing right here. That's the same thing as X over Y. All right, so let me rewrite the original equation that you were given right here. So I've rewritten the given equation. And again, we want to get X by itself on top. All right, so if I asked you, if I gave you that equation, I'd say, well, how do you get X by itself on the left? You guys would say, well, divide both sides by 24. So let's do that. The 24s on the left-hand side cancel out and make a 1. So now we have X equals. And I purposely kind of wrote this at like on the right-hand side, I've got 9/24 times Y, like that. That Y floating in the middle there on this fraction right here, that really implies that that Y is up on top in that numerator. All right, well then to finish it, I just need to get Y on the bottom, on the left-hand side. And to accomplish that, I just need to divide both sides by Y. So let's do that. So I'll divide the right-hand side by Y, and I'll divide the left-hand side by Y. On the right-hand side, y over y, well, that cancels out and that makes a 1. So now we have the ratio x to y, or x over y, equals 9 over 24. Now you could reduce that. So if you divide, let's see, divide the numerator by 3, you would get 3, and divide the denominator by 3, and you would get 8. So that would be the reduced form of your ratio x to y. All right, we've only got 2 problems to go here. These are our story problems, but we're going to use proportions to solve these. And when we do that, I think you'll find that these are some of the easier story problems that you could do. As long as you set them up consistently, you will get the correct answer. So let's see what we can do with this one. So number 11. So it says 3 pounds of apples cost 90 cents. And then it says, how much would 10 pounds of apples cost? So what we want to do here is we want to set up our ratios. So let's go maybe dollars over pounds. So let's make a note of that. So I'm going to want to set up my ratios as dollars over pounds. And as long as I do that with both of my fractions, again, we're setting up a proportion where we have 2 equal fractions. As long as I'm consistent, it should work out just fine. So let's set them up. I've set up my equal ratios, and I have them both in dollars per pound. So what we should see here then is these 2 quantities form a ratio. It's 90 cents for 3 pounds of apples. So those 2 values go together as one ratio. We have 90 cents for 3 pounds. And then we should be able to see then that the other number we're given is 10 pounds. So the 10 pounds will go over here in the denominator on the right. And we're trying to solve for how much will 10 pounds cost. So it'll be X dollars. So again, as long as we're consistent, if we do dollars over pounds, then the other fraction should also be dollars over pounds. Now we just cross multiply, or I should say we do our cross products and set them equal. And we will solve for how much 10 pounds of apples cost. We'll do our 2 cross products, just like that, and set them equal. Our first product, cross product, will have 3 times x, so that's 3x, equals, and then our other cross product will have 0.90 times 10. Well, that'll give us 3x is equal to, well, 0.90 or 90/100 times 10, that's just 9. And then we'll just divide both sides by 3. And we will get x equals 3. And since we are doing a story problem here, we want to put units on our answers. Well, x again is 3, and that's what we were looking for, is this x in this numerator. You can see that we were looking for the dollars, right? So we're going to make our final answer. We'll make that x equals $3. Well, we're finally on the last problem here, problem number 12. So let's read this one. This one says John has 30 marbles. 18 are red and 12 are blue. Jane has 20 marbles, and all 20 of them are either red or blue. Then it says the ratio of red to blue marbles is the same for both John and Jane. Then the question is, how many blue marbles does Jane have? Now this is a little bit tricky because when you see the ratio of red to blue, so we've got red to blue, you think you're going to set it up like for John, you'd have 18 red over 12 blue. But that's not going to work because what you're given here is the total for Jane. So let's highlight this. So Jane has 20 total marbles and John has 30 total marbles. Now, it's because that these marbles are in the same ratio for both John and Jane that we're able to set it up this way. All right, so let's set this up as, let's set it up as blue marbles over total marbles. So let's just be consistent with that, and we'll do it for each of them, okay? So for John, we'll set him up right here, and for Jane, we'll set her up right here. All right? So then I've set up my proportion, my two equal fractions. And for John, I'm going to set it up as blue over total. And then for Jane, I'm going to set the ratio up the same way as blue over total. And as long as you're consistent, this will work out for you. So let's see what we've got. So for John, he had 30 total marbles. So he's got 30. John's got 30 total. And it also says that John has 12 that are blue. So there's 12 that are blue for John. So we will put 12 in the numerator of our ratio for John. And then I also highlighted in green up there that Jane has 20 total marbles. And we're trying to solve for how many blue marbles does Jane have. So that'll be our X. Now we're just going to do our cross products and we'll be all set. Now I want to point out one last thing. You could actually reduce this fraction first if you wanted to. All right? Because you could divide both of those by 6. And you would get some smaller numbers to work with. So if you divided the numerator by 6 and the denominator by 6, this ratio for John would actually become 2 over 5. But it won't matter. You can just leave it like it is and you can still do your cross products. So let's do that. So our two cross products are 30 times X. That will have to equal 12 times 20. I'll write that, so I'll have 30x equals 12 times 20. That gives me 30x equals 240. Then we'll just divide both sides by 30. And we'll get x equals 8. Now we should probably say what it is that we solve for again when it's a story problem. So in this case, it was how many blue marbles Jane had. So Jane has 8 blue marbles. And that's it. There's all the examples for section 7-1. Guys, thanks for watching, and I'll see you in class soon. Bye.